sixth graders, today we're going to start variables, so make sure that you have your notebook ready to take some notes. So things to think about while we watch this first video. What part of the experiment did they change on purpose? What part changed as a result of what they changed? And what did they keep the same? So you're looking for three things. What did they change? What were the results? And what did they keep the same? Mythbusters.
Do not try any of the experiments you are about to see at home.
You heard it. Don't do it.
In the myth of the 5-second rule, Adam and Jamie have decided to make a uniformly filthy piece of floor. That way, when they drop food on it, they should get consistent contamination.
So I see some pans.
We have some tiles.
Floor tiles.
We have beef broth. And we have some pans.
For some reason, whenever I see the pans, I have the desire to smash them on my head. You ready?
Yeah.
See if we can get a perfect face print.
So with that out of the way, what's the plan?
So the plan is that once we get these trimmed down to fit in pans, we're going to pour beef broth into
What's beef broth? Is it beef broth? They leave the floor tiles to rot in the boudoir, and Adam turns his attention to another mini myth.
I've always heard that a dog's mouth is supposedly cleaner than a human's mouth. I'm gonna lick this sterile agar plate, and we're gonna get Lulu the dog to come up and lick this one, and we'll just see whose mouth is cleaner.
So this has got nothing to do with the 5-second rule. We're just comparing your hygiene to a dog's, right?
Not my hygiene, the human's hygiene in their mouth to a dog's hygiene. I guess empirically what we will be testing is my hygiene against Linda's dog, but
Just do it. Just lick the darn thing.
all right, here for science.
Yuck.
Doesn't taste like anything. Where's the dog? Bring on the dog! Want to lick this feral agar plate? Oh, Lou, that's perfect. Thank you. Good girl.
Is it just me, or does Lulu look quietly confident? Time will tell. Back at the myth of the 5-second rule, the floor tiles are fully festered.
What, 5 days now?
They smell really, really bad.
Yeah, I know. Let's get them out, hang them up, and dry them off, and see if we can use them today.
Jamie punches out plastic templates which will ensure sample sizes are consistent. While they're sterilizing in the microwave, Adam gloves up.
Coming up, Mythbusters takes Microbiology 101.
Adam has to behave like this. It's in his contract. But whatever you do, don't do this at home. To test the 5-second rule, they'll use a wet food, a dry food, and an evenly contaminated floor tile.
It's science.
Samples of wet pastrami and dry crackers are exposed for 2 seconds and 6 seconds. In other words, for less than and more than 5 seconds. They also do a control on samples that don't touch the floor at all, in case they are already coated with bacteria.
Roll number 2. I know I love building big things and blowing stuff up. This is also super, super fun.
Okay, fishing out a new one.
He doesn't care.
And go.
And the bulk of our Mythbusters bacteriology test is done. Cool. Can't wait to find out what happens.
All right. So we don't actually get to see the results. If you want to see the results, I'm sure you can find that episode on YouTube somewhere. If you notice, they do 2 different experiments in this video. We are going to focus on the 5-second rule experiment. So in your notebook, you're going to draw the organizer, the graphic organizer on the next slide. Make sure your boxes are big enough for you to write in. I will show you mine so that you know what it is supposed to look like on your end. So here is mine. If you notice, I have just 3 boxes, and then the thing at the bottom, space big enough for you to write in. There you go. At this point, if you need to pause the video to copy it, go ahead and pause the video. If you're one of the super cool kids that got it printed out because I emailed it to your parents and it's available on the Canvas page, cool, great, wonderful. I am more of a draw it myself type of person, but you do you. All right, here we go. So you're going to fill it in slide by slide over the next couple slides as I talk about it. So a variable is something that you can change if you want to, if the experiment calls for it. Next up is the independent or manipulated variable. Manipulated is just a fancy word for change. So the independent variable is the one thing that you are changing in an experiment. An experiment is usually to only test one thing. So you are only changing one thing. The next one is the dependent or the responding variable. And this is the variable that you measure. These are your results. So the variable you measure in an experiment, your outcome, your results. And the constants or control variables are the variables that you're keeping the same. So what does not change at all? What stays the same for every single trial, for every single test? And then the information that's on the next slide goes in the little bottom portion. So the I need to remember. And then hopefully you drew this graph a little bit bigger because this is super, super tiny. So I need to remember only one variable can change. Then, these are acronyms to help you remember the difference between independent variables and dependent variables. So, independent variables, you need to remember I, chop. So think of karate. Okay? Independent changes on purpose. I chop. And then for the dependent variable, think of drum. Dependent results you measure. So drum. So now hopefully your notes page is all filled in, or the first page of your notes page. All right, now on this one, if you have the printout, awesome. If you don't, you have quite a bit of writing to do. So if you need to pause the video at any point in order to write these sentences, please, please, please pause the video because this is important information for you to have. So there are a couple rules that you have to keep in mind when talking about experiments. Rule number 1 is that you have to have a testable hypothesis. A hypothesis is a statement, maybe, technology issues, all right. A statement of what the scientist is testing. So, if the dog licks the agar plate, then we will have results. So, a hypothesis is a statement of what the scientist is testing. A hypothesis is testable if at the end of the investigation you cannot confirm or disprove the statement. So think yes or no. So a hypothesis is testable if at the end of the investigation you can confirm or disprove the statement. Was it true? Was it false? Did it actually happen? Okay, rule number 2, you can only change one thing. I'm pretty sure I said that about 10 times earlier. And these are just your definitions over again. So the independent variable is the variable we change in the experiment. The control variable cannot be changed. It must stay the same. And then the dependent variable is what we measure. It's the results. Okay, rule number 3. You need valid data. So you want to do this test, but if you don't have your data, if you don't have the things that happen, then you won't have any information to share. So scientists will often do repeated trials to make sure that their data is accurate. So if you do it once, it may end up great. But if you do it 5 times, you may find out that it only works 3 out of the 5 times. So repeated trials help scientists become more accurate. Rule number 4, communicate your data. So you did an experiment, cool. What are you going to do with that data now? Does anybody care? Yes. So you need to communicate it. You're going to use charts and graphs to help give a quick picture of the data that they collected, or that you collected. Charts and graphs are easier for people to read because it makes them visual. If you put a bunch of words on a piece of paper, people aren't going to read it. But if you do visuals, then people pay attention. And then rule number 5, draw reasonable conclusions. The conclusion should have evidence or support from the investigation. So if you just tell them what happened without anything to back it up, are they going to believe you? No. All right, so let's go back to the Mythbusters video. I'm not going to make you watch it again. You can go back in this video if you want to watch it again. So what is the independent variable in the investigation? So what did they change on purpose? Now if you think back to the video, they changed a couple things, so they didn't really follow the rules. But what were they really testing? Does anybody know? The types of food. If you said the amount of time on the ground, technically you're right. What's the dependent variable? What are they measuring? The amount of bacteria growth. How much yuck gets on the food. And then 3 things that stayed the same. The type of floor tile, so that white tile. The type of stains on the floor, so when they put it in the beef broth for the 5 days. And then they used the same testing supplies. So they used the same little circle, they used the same type of swabs, they used the same type of food, and they used the same area where it was tested. So you'll see that all 3, independent, dependent, and the constants or the control variables, were all included in their investigation. So let's practice. Yes, I want you to try and answer these before I do. And yes, it's weird because we're not actually together and you're just watching a recording. But hey, we're going to be awkward together. Okay? Here we go. So let's say we wanted to know which brand of sponge could absorb the most liquid. So you have the green and yellow sponges, you have the dollar store sponges, and then you have the super fancy $9 sponge. But we just want to know how much water they absorb. So the dependent variable is the one that we are measuring. Yeah, I pretended that I heard y'all. So in this case, the dependent variable is, so what are we measuring? Good job if you said the amount of liquid absorbed. The independent variable is the one that we are, remember there can only be one of these, changing. Yep, heard somebody in the back. Good job. So in this case, the independent variable is the brand or type of sponge. And there could be about 1 million controlled variables here, but here are just a few. So the type of liquid, the size of the sponge, the color of the sponge, the room temperature, who squeezes the sponge, what sink you use. Like I said, there could be about 1 million different controlled variables. So let's practice. I'll read this for you since it is kind of small. Miss Fink cuts a red apple in 4 equal pieces. She places 1 piece of apple into identical Ziploc baggies. In bag number 1, she pours in 1/4 cup of vinegar. In bag number 2, she pours in 1/4 cup of Sprite. In bag number 3, she pours in 1/4 cup of lime juice. For bag number 4, Miss Fink does not add any liquid. All baggies are zipped closed and placed on one of the science tables in her classroom for 3 days. After 3 days, Miss Fink observes how much browning has occurred on each apple. She was very intrigued by the results. So, bag 1 has vinegar. Bag 2 has Sprite. Bag 3 has lime juice. And bag 4 has no liquid. So in your notebook, I want you to write this. So make a hypothesis. I think the apple slice in blank, so what kind of liquid, will have the least amount of browning. And then I want you to try and guess the independent variable, the dependent variable, and then list 3 controlled variables. I'm going to give you about 2 minutes or so to try and write this down, and then we'll check it together. All right, so everybody's hypothesis will be different, so I'm not even going to go over that. So the independent variable, what did we change on purpose? If you wrote down the type of liquid, give your brain a high five. Ooh, good job, brain. The dependent variable. What are we measuring? The dependent results you measure. If you wrote down anything about browning on the apple, give your brain another gentle high five. Whoop. Good job, brain. And then the controlled variables, again, there's about 20 of them. I'm going to list 4. So the type of apple, it's a red one. The room, because we said on the science table in her classroom. The type of baggie, because they're all Ziploc baggies. And the amount of liquid. Because remember, we put 1/4 cup into all of the ones that had liquid in it. Now, some of you may be wondering why we left the 4th bag empty. That's another type of control in an experiment. You always leave something without anything affecting it. And that's a controlled part of the experiment as well. So you will use these notes for your quiz on Friday. We will practice more tomorrow with different scenarios. Some of you will practice online by yourself. Some of you will practice in Zoom with Miss Williams. If you need to review this lesson, you can go back and watch it as many times as you need to. You will get to see my awkward face every time. So, you're welcome.